Let's talk about measurement units and the metric prefixes. So measurements consist of a number and a unit of measurement. If I don't get the unit with the number that you measure, suppose you measure 1.54, okay? I have no idea what you're talking about. I have to get 1.54 centimeters, okay, or seconds, or kilograms. I have to know what quantity that you're measuring in order for me to give you proper credit. So any answer that does not have a unit gets a -1 on every problem. Okay, so make sure that you're writing units every single time that you give an answer. So with measurement, there are certain quantities that we measure in lab and around the scientific community. Time is a basic one. You might use a clock, you might use a stopwatch, you might use an app to do this. Okay, the SI unit is going to be the second, and we're going to abbreviate that with a lowercase s. Okay, so a measurement of 100 seconds would look just like this in your lab notebook. Mass, we will use a balance, usually a digital balance. Okay, there's a video on significant figures in measurement that talks about digital versus analog, but a balance will measure mass, and kilograms would be our SI unit. And our symbol for this is the metric prefix of lowercase k followed by lowercase g for grams. For length, we have the meter stick or ruler. In lab, we might have a ruler. Okay, any number of things. Calipers measure length. Okay, so there's a number of different instruments that can measure length, and the SI unit will be the meter. Abbreviation lowercase m. Temperature, thermometer. Thermal conductivity probe, forehead scanner, a lot of things that can measure temperature. Okay, and SI unit is going to be the Kelvin. It's going to be abbreviated capital K. Usually though, degrees Celsius is measured in the lab. However, the SI unit is Kelvin, so we'll talk about the difference at a later time. Volume can be measured with a graduated cylinder. For liquids, okay, so measure the liquid volume. If there's a solid, you might have to derive volume using 3 measurements of length, for example, or you can measure by difference through water displacement, which we'll talk about at a later time as well. However, with volume, the SI unit is the liter, abbreviated as capital L. For each of our units, we can scale their values based on large and small using several prefixes. Okay, and so we can start with large, mega, then kilo, and then go less than 1. Okay, these are all greater than 1. Now less than 1, we have deci, centi, getting smaller, milli, micro, and nano. Okay, for this course, we'll use these prefixes. And so the abbreviation, capital M, this is our prefix, lowercase k, lowercase d, lowercase c, lowercase m. Note that looks a little bit like meter. Micro is a script m. Nano is a lowercase n. What do they mean? Well, mega means times 1 million. In powers of 10, that's 10 to the 6. Kilo means multiply by 1,000. Deci means multiply by 0.1 or 10 to the minus 1. Centi, 0.01 or 10 to the minus 2. So divide by 100, for example. Okay, means the same thing. Milli times 0.001. That's a power of 10 to the minus 3. Just multiply by either of these two quantities. These are all equal. Okay, micro means multiply by 0.00001, and that's 10 to the minus 6. So a little easier to write 10 to the minus 6. So check out the scientific notation video for more clarification. Whew. 9, 10 to the minus 9, 8 zeros and then a 1. So multiply by that factor when you're using each of these prefixes. Okay, so the prefix and the meaning are interchangeable with one another as far as converting from one unit to the base unit. So let's look at this. Let's talk about using these prefixes and writing these units that I've given you here and converting them to a base unit. So 320 megagrams would look like this. Capital M, lowercase g for grams. So we combine the prefix with the base unit. Okay, not necessarily the SI unit, kilograms the SI unit, but the base unit is grams here. So what does that mean? It means the meaning of mega, we said, was multiply by 10 to the 6. In scientific notation, as you'll see later, and you can use this as extra practice. Okay, pause and practice if you want to with scientific notation. But when we move to the left, 1, 2, we have to add 2 more. Okay, so those things are equal to one another, and this last column is scientific notation. So 400 nanometers. Lowercase n for the prefix, m for the unit. What does nano mean? It means 10 to the minus 9. 400 times 10 to the minus 9 meters. In scientific notation, we move to the left, so we add 2 to get 10 to the minus 7. 600 millimeters. Lowercase m for the prefix, lowercase m for the unit. Okay, so don't let that confuse you. The difference between prefix and unit there. 600 replace with the meaning. Milli means 10 to the minus 3, or we could write it as 0.001, whichever way you like. It's better for you to learn the powers of 10 because it's easier to convert to scientific notation. Moving to the left, 6.00 times 10 to the minus 1. Move 2, 1, 2, add 2 here. Negative 3 plus 2 is negative 1. And we get our scientific notation. What about liters? 60 liters. Well, it's already in the base unit, so we're done here. Okay, in the base unit. Now, if we wanted to do scientific notation, we could say 6.0 times 10 to the 1. Okay, move over 1 times 10 to the 1 liters. 52 kilokelvin. Lowercase k, capital K. In Kelvin, what does kilo mean? Kilo means 10 to the 3. These two things are equal, just like we've been saying. Okay, the meaning and the prefix are interchangeable with one another. Don't forget the units. 5.2 times 10 to the 4 kilokelvin. Okay, so we should be able to take all of our problems and convert our units to their base unit using this method. We'll look at more ways to do conversion factors in a different video, but as far as the meaning of units and writing our units, we should be familiar with these devices, prefixes, and unit quantities for the first exam.